So question 2 is all about functions. We're told in part A that the graphs of f of x is equal to 5 over 2 to the power of x and g of x is equal to mx plus c are drawn. A, which is point x is equal to 1 and y is equal to 5 over 2, is the point of intersection of the two graphs. Point B, 0 and 11 over 2, is the y-intercept of G, and C, 0 and 1, is the y-intercept of F. All of this information is in our graphs, and maybe we can just highlight it. Let's make this point pink. This point belongs to the exponential, and let's make the points of intersection in a brighter color. There we go. And then this is the x-intercept of G, which is the point D, 11 over 6. Question 1 asks us to determine the values of M and C. So graph G is a straight line graph, mx plus c. So we need to find the gradient and we need to find C. We know that C is the y-intercept. So C is 11 over 2. Now we can just substitute C into this equation by using any one of these points. So let's use the point A. A is 1 and 5 over 2. So we'll have 5 over 2 is equal to, M is what we're looking for, x is equal to 1 plus 11 over 2. So M times 1 is just M. So M is equal to 5 over 2 minus 11 over 2. 5 minus 11 will give us negative 6 over 2, which is negative 3. So C is 11 over 2, M is negative 3. Question 2 asks us to determine f negative 1, which is the inverse of f, in the form y is equal to. So our graph for f is given by f of x is equal to 5 over 2 to the power of x. This is an exponential function. So we know that the inverse of an exponential is given by the log. So y is equal to log. Our base is going to be 5 over 2 times the exponent. So the inverse of f is y is equal to log base 5 over 2 x. Then we're asked to write down the domain of f of x, but of the inverse function, sorry, the inverse of f, but not just the inverse of f, the inverse of f at x minus 2. So x minus 2 tells us that our inverse function is experiencing a horizontal shift and this is 2 units to the right. So our inverse function would be in the fourth quadrant, since it would be flipped over the x-axis, and it would be shifted 2 units to the right, so away from the origin, so x would have to be greater than 2. So I want us to just be able to visualize this for a second. So we're going to head over to GeoGebra. And here we can see that the graph of f of x, our original graph, which is given by 5 over 2 to the power of x, looks like this. And that's what we were given in our question. Oh, let's make that a little bit bigger. There we go. Now, when we take the inverse of the function, which is the log graph, it looks like that. reflected about this line y is equal to x. And when it's shifted 2 units to the right, we can see that x has to be greater than, x has to be greater than 2, because this line x is equal to 2 now becomes our vertical asymptote. All right, let's move on to question B. On the grid below, we're asked to sketch the graph of f of x is equal to 4 over x minus 2 plus 3, showing all of our asymptotes and our intercepts. Now, this graph is the graph of a hyperbola. Before drawing our function, we want to actually just take a look at all of the information that we have. And so we can see that we have an a value of 4, so a is positive. And we know that when a is positive, our hyperbola exists in quadrant 1 and quadrant 3. Then we can take a look at the asymptotes that we have. So we have y is equal to 3, or q rather is equal to 3. And this is going to be our horizontal asymptote. At y is equal to 3, it's a horizontal asymptote. And x minus 2, we know we can take x minus 2 and make that equal to 0 to find our vertical asymptote, which is going to be at x is equal to 2. And then we can find our y-intercept and our x-intercept. So let's start off with our y-intercept. We know for our y-intercept, we'd have to make x equal to 0. So this would be 4 over 0 minus 2 plus 3. This would be 4 over minus 2 plus 3. And that would be negative 2 plus 3, which is equal to 1. So our y-intercept is 0 and 1. So let's make this 0, 1. It's going to be our y-intercept. Let's see if we have an x-intercept. So to get our x-intercept, we make y equal to 0. So 0 is equal to 4 over x minus 2 plus 3. This would give us negative 3 is equal to 4 over x minus 2. We can multiply the denominator on both sides. So this will leave us with negative 3x plus 6 is equal to 4. We can subtract 6 on both sides, and we'll have negative 3x is equal to negative 2, dividing both sides by negative 3. X is equal to 2 over 3. So this is going to be 2 over 3 and 0 for our x-intercept. All right, now we have all the information that we need in order to draw a graph. We don't even need to use our calculators. So we can start by drawing in our asymptotes. So let's draw in y is equal to 3. So this would be 1, 2, 3. We can just use a dotted line to indicate our asymptotes. This would be y is equal to 3. Our vertical asymptote is at x is equal to 2. So that would be 1, 2. And label this x is equal to 2. We found our y-intercept, which is at 0 and 1. So we'll go down to 0 and 1, which is over here. Label our point. We have another point, which is our x-intercept, which is at 2/3 and 0. So that would be between 1, just after a half. So this would be somewhere here. And now we can use our calculator to get some additional points and connect our graph like this. And we know the rest of our graph is going to exist somewhere here. Let's draw this a little further down. You can use your calculator to find more points, but the only points you're going to get marks for are your asymptotes, your intercepts, as well as your x and your y intercepts and your asymptotes, because it's 4 marks. So you basically just need to draw a sketch. So you don't need precise points. Now we're asked to determine the axis of symmetry of f, which has a negative gradient. So f is this graph that we just drew. And remember, the axis of symmetry exists between our two asymptotes. So it would be this line over here. And the axis of symmetry has a gradient of 1. So it's a straight line with a gradient of 1, but it's -1 because we're told that it has a negative gradient. So we take the line y is equal to -x plus c. We'd substitute a point, since we know that y is equal to 3 over here and x is equal to 2. We'd substitute the point 2 and 3 into this equation. So we'd have 3 is equal to -2 plus c. If we add 2 on both sides, we find that c is equal to 5. Therefore, y is equal to -x plus 5. That is the equation of the axis of symmetry of f with a negative gradient. Let's go over to question C. We're given p of x, which is equal to 3x plus 1 divided by x minus 2. We're asked to rewrite p in the form px is a over x minus 2 plus n, where a and n are integers. So we're going to use polynomial long division to get to this rewritten form. So we're going to start off by dividing term 1. Term 1, which is 3 of x. So we're going to say 3x divided by x is equal to 3. Right? And there we found our quotient. So to find your quotient, you divide your first terms by one another. So 3x divided by x is equal to 3. Next, we're going to multiply the quotient by the denominator. So our quotient, which we know is 3, we're going to multiply that by x minus 2. And that's going to give us 3x minus 6. Now, we're going to subtract our numerator from 3x minus 6. So this is going to be 3x plus 1 minus 3x minus 6. So 3x minus 3x is 0, and 1 minus 6 is 1 plus 6, and that gives us 7. And this is our remainder. Now we can rewrite p. Therefore, p of x is equal to, a is our quotient, or our remainder, which is 7 over x minus 2 plus n, which is our quotient, which is 3. So p is rewritten as 7 over x minus 2 plus 3. And now for the last question, in question 2, part D. In the figure below, the graphs of f negative 1 with the equation f negative 1x is equal to negative square root x minus 2, the inverse of f, and g with the equation g of x is equal to negative 1 over 3x minus 2 are drawn below. The graph of g intersects the x-axis at B and the y-axis at A. E, the point xe, and 0 is a point on the x-axis. C, with coordinates xc and yc, is the point of intersection of the inverse of f and g. G and f are points on G and the inverse of f respectively, and EFG is parallel to the y-axis such that 0 is less than xe and CE is less than xe. Question 1 asks us if the inverse of f is a function. So in order to find out if a graph is a function, we need to perform the vertical line test. So the vertical line test is a visual way to determine if a graph is a function. And remember, a function by definition is when we have one output value or a value of y for each input value of x. So our vertical line test proves that a graph is a function if a vertical line intersects the graph a maximum of 1 times. So if we go to the inverse of f, which is this curve over here, and we draw some vertical lines at different points of the graph, we see that there is only one intersection with each vertical line. So the answer is yes. The inverse of f is a function, and there's a one-to-one correspondence for the vertical line test. And that's it. Next, we're asked to determine the equation of the function f in the form f of x is equal to. So now we have the inverse of f, so now we need to find the original graph f. So let's look for the equation of the inverse of the function. So f negative 1x is negative square root of x minus 2. So y is equal to negative the square root of x minus 2. We're going to swap x and y around. X is equal to negative square root y minus 2. Now we're going to get y on the one side. Square root y is equal to negative 2 minus x. We're going to square both sides to get rid of the square root. So this is going to be y is equal to negative 2 minus x squared. Therefore, f of x is equal to negative 2 minus x squared. However, x always has to be greater than or equal to 2. Otherwise, our graph is going to be equal to 0, and that wouldn't be a function. And that is it. Question 3 asks us, the position of the vertical line GF is variable such that x of A is less than x of E, which is less than x at C, or the x coordinates at point A, E, and C. We're asked to determine the length of the vertical line segment GF in terms of x. This, very simply put, just means that GF is going to be the difference in the y coordinates at G and the y coordinates at F. And if we go back to our function, there we go, we see that this line GF is the distance between the inverse of f negative 1, and the function g of x. So we can write this as g of x minus the inverse of x. And the equation for g of x is negative 1 over 3x minus 2, negative 1 over 3x minus 2 minus negative square root x minus 2, which is the equation for the inverse. And we want this in terms of x, so this is going to be negative 1 over 3x minus 2 minus square root x minus 2. So minus 2 plus minus 2 minus minus 2 is minus 2 plus 2. So that's going to give us 0. So GF is given by negative 1 over 3x plus minus minus square root x, which is plus square root x. And that is it for question 3. And that's it for all of question 2.